Hello learners, welcome to our YouTube channel LearnWebCloud. Today's topic is how to build a scalable web application. So before we start, let me explain what is scalable web application. A scalable web application will be able to handle an increase in users and load application without disrupting the end users. A successful web application need to be seamlessly and efficiently accommodate growth and be designed with scalability. For an example, recently after TikTok ban, many apps in India has gone through scalability phase where more than 2 lakhs users are accessing application like Chingari, Roposo concurrently. So we will go into detail step by step for building layers of a scalable web application. After completing this video, you will learn these things: highly scalable web application architecture, web application resources without cloud service, load balancer, database cache, latency delay points in web application, business intelligence, content delivery network, data warehouse. Let's take an example of a web application chat box where user can log in, add group, chat with friends. User can add media or video file. We will add more complexity and requirement later. So here is high level architecture of our chat box web application. Let's go in deep for each steps here. First, we bought a domain name chatbox.com from domain naming service. User can connect chatbox application using devices via internet. So we deployed our developed application on web servers, which will have its own disk space, operating system as well. Usually web server will have Apache server installed on it, which will receive a request on port 8080 and serve browser request by the user. So to be best practices, we add a load balancer here, which can be a hardware or software. The main purpose of load balancer is to watch the incoming traffic request and route the request on available web server so that web server can give response efficiently to the user. For backend related API, we added applications server as another machine. This server machine little bit different with web server machine, as these servers will have our business logic component and that can be trigger notifications like email or SMS, because in our application it might need that user need some email confirmation and SMS on their mobiles. So these are the business services which will be triggered at the application server machine. Okay, so now here we will go each layer here. So this one is internet facing load balancer, which will only see the request which is coming directly from the internet. This is our user interface layer where our static page or dynamic pages content will be in user interface layer. This one is internal load balancer, which will only see the web server request, and this is our business layer, or you can say service layer, which will uh, having those services which will required at this business layer or business component. So before we go further, let's take a look here. We have four web server and we have four app server. We can connect directly one web server to the one app server. Yes, we can do, but there is a problem. What happen if one of your app server is down? And because you are connecting from your web app server to app server directly, so the request which is coming to this web server will not be fulfilled. Why? Because this app server is down. So, and the same thing happen with this web server as well. If this web server is connected with this app server and this app server is down, then the request coming from this web server will not be fulfilled. So that's why we placed internal load balancer, which will see if this app server is down or this app server is down. It will route all the requests to these two available app server. So here is that you need to keep in mind that load balancer can be a internet facing load balancer or internal web request facing from the web server end. Now we will add most important part, database, or which we can say that database layer. So database part where we will add our user information or our business related data to the database. We can use relational database or non-relational database. Relational database can be Oracle, MySQL. Non-relational database can be Mongo database or DynamoDB. We will make a separate video on both these type of database based on our use case. Okay, so now our application is being accessible to the users and user is increasing. So after beyond a certain user size increased, user will feel some latency issues, means user can have user can feel that there is a delay in while receiving the response in the browser. So for avoiding that delay points, we will do two things. First thing is we we already choose two database. One is like primary, which is called as a master database. Another one is replica, that is called a slave database. So what we do, we primary data or primary or master database will have operations on like writing new records from the user or updating records from the users, while replica database or slave database will have all the records asynchronously from that primary to its database, so that any users if trying to read any records, it will read from that replica database. Here if you notice, we are directly or every time reading database or writing database. So suppose in some cases if users just need some information, it will have to fetch a record from the database. So the second things which we will do, we will add a database cache layer. So instead of reading every time from the database or writing record into the database, we will see if that information already available in the cache or not. If the information is available in the database cache, then the information will be returned from the cache itself. In that case, user don't need to fetch a record from the database. If the information is not available in the database cache, then we will fetch record from the database. We will put back into that cache and return that information to that user. So in this way, we can avoid multiple read write from the database. Instead of, we will providing the information from the database cache. Database cache is a distributed cache, and we also called it in-memory database. So again, we can decide which flavor of database cache is required. Memcache and Redis are popular flavor of in-memory database cache. So adding this database cache layer will increase user accessibility to our application, and there will not be a latency issues while fetching record from the database. Now our application is working fine. At least for this point, there will not be a latency issue. Now let's talk about where that user media files will reside at our end. Definitely we will not add user media files at our web server, because these user files should be accessible very fast. If we placed media files at web server disk space and same web server is down, so user will not be able to access its files from this web server. So we will add user files at external storage. So this is the external storage where all user media files will be available, and these media files will be provided to content delivery network, means caching all user media files to this content delivery network. This content delivery network will have its own cluster of servers which will fetch these files and will store inside this network, and all user media files will be provided to the users. So first time if user is trying to access its media files, then content delivery network will fetch that file from that external storage and will put inside its cluster, so that next time onwards when user trying to access its media files, those files will be given from that content delivery network itself. It will not go again to fetch those files from that external storage. So here if you can see, by adding these two resources, CDN, that is content delivery network, and database cache, our user will not feel any latency issues. So these 2 points, remember, if you apply this in your web application architecture, user will be access application, its data and media files very efficiently. So now what is next? We want some analytics on users data, like what user is trying to access, what he is like to do, so that based on users preference we can provide some additional features so that we can grow our application based on that user preferences. So definitely we wanted to add some analytics on that users data, or we can say the pages which user doing some activity. So here you can see we have some stream analysis. There is a one resource which will streaming each and every click on that user's page, and it will fetch all that raw data records. It will fetch and store all the record in a external storage. So here all that raw data will be collected by the Spark. Spark, basically what Spark will do, it will do analysis on that all the raw data. It can fetch the record if it is not in, like not in SQL format, and it can also fetch the record from our primary database in that SQL format, and it will do the aggregation process, means all the aggregation on that raw data and the best way from that database itself, and it will represent in a way so that it can be stored into the data warehouse. So this data warehouse will have all this data so that it can be used for the analysis. So our business intelligence tool will fetch all the data from the data warehouse, and it will show that users data in a better format, like graph, lines bar, and in many format, so that no the application stakeholder can see how the user is accessing our application, what their new requirements, so that they can add new features to the application. So here this is all the resources which is required for a scalable web application. Apart from mentioning all the resources, we also need a monitoring dashboard which will actually tell us what the status of all the resources which is we have placed in our architecture, so that if there is a problem with any web server, app server, or database, we can visualize this, and we can take action accordingly to that our problem. So I hope you enjoyed this session. So please subscribe and like our YouTube channel, Learn Web Cloud. Be happy and keep learning at Learn Web Cloud. Thank you.